This video will help you understand how to configure flow settings on your BaseStation 3200 for irrigation systems with more complex hydraulics, sites with multiple water sources or multiple mainlines. For sites with simple hydraulics, one water source and one mainline, there's another video you'll want to watch instead. Before we do any setup, it's a good idea to sketch your site hydraulics out. My site looks like this. Water source 1 is a 3-inch water meter with a 2-inch master valve and a 2-inch flow sensor. Water source 2 is a 2-inch water meter with an 1.5-inch water meter and an 1.5-inch flow sensor. Both are connected to the same 3-inch mainline that I'll call mainline 1. There are many different combinations, so a simple sketch goes a long way in setup. Begin by opening a web browser and going to baselineapps.net and then log in with your username and secure password. Look for the Base Manager icon on the left side of the screen. Before we get into flow setup, we'll want to verify that our flow devices are already assigned. Click on the Devices tab and then look for all of your master valves in the assignment list. I don't have any pumps, so this section is empty. There are 2 flow meters on this project, and they both show up in the list as well. This project has slightly more complex hydraulics, 2 master valves, 2 flow sensors, and 1 mainline. Now that we have devices to work with, click on the Flow Setup tab. Select Water Source 1 and then Edit in the lower right corner. It's a good idea to name your water sources so they make more sense to you. I'll add a description to Water Source 1 to reflect its location. Water Source 1 is enabled by default, so there's no need to change that, and I'll leave the default water source priority alone. We'll come back and revisit water source priorities a little later. This water source is associated with control point 1, and there are 7 other control points available. Just now I've set a monthly water budget of 100,000 gallons and then selected Shutdown. When more than 100,000 gallons have passed through this water source in a month, it will alert me and then disable or shut it down. When you're all done with Water Source 1, press Save before exiting. Since we have 2 water sources, we'll need to edit the second water source. I'll name it like I did with Water Source 1 and then enable this water source. I'll leave the water source priority at its default setting, but I am going to assign or associate it with control point 2. Save your work before going on to control points. The next item to set up within Flow are control points. I'll be working on control point 1, so open it and then select Edit. I'm going to name control point 1 and reflect its location. This control point is already associated with mainline 1, although I could associate it with different mainlines on more complex systems. Now to my flow limits. I'll set the design flow to 100 GPM, which I based on the size of my control point. I looked up this information in a pipe friction loss chart, but if you're not quite sure how to find this info, your baseline distributor or baseline rep can help. I'll try out an additional 20% for the high flow limit, or 120 GPM, and then select Shutdown. The design flow means that I'm okay with 100 GPM all day long, but should it ever exceed 120 GPM, it will alert me and shut down. I don't have any pressure transducers on this project, but if we did, I would set pressure limits here. Unscheduled flow is flow that runs without the controller knowing about it. An example is someone using a quick coupler or manually bleeding a valve. Both pull water from the mainline without the controller knowing about it. I decided not to select shutdown, so anytime someone uses more than 20 GPM of water, I'll get an alert, but it won't shut down. The last thing to set are devices in the control point. Since I've already assigned devices under the Device tab, I have 2 flow meters available in the dropdown. It's important that you select the correct serial number from the list that you kept during installation and don't mix up the devices. Notice that the pulses per gallon and K value automatically populate because this is a baseline flow sensor. If it's a different flow sensor and you're using a flow bicoder, you'll need to input your own K value to get an accurate flow reading. My more complex system has 2 master valves in the drop-down menu, so make sure you select the correct one. This first master valve is normally closed, so I'm going to leave the normally open box unchecked. If I had a pump or pressure sensor, I'd be able to select them here. That's all for control point 1, so save it before going on to control point 2. On control point 2, I'll name it like I've been naming the others, then ensure it's enabled. This time I'm going to assign or associate control point 2 with my only mainline, which is mainline 1. Control point 2 is smaller, so it only has a design flow of 60 GPM. I'll set the high flow limit about 20% higher or 75 GPM and have it shut down if it exceeds that 75 GPM. I'll set the unscheduled flow to 20 GPM just like I did for control point 1. We need to select devices just like we did in control point 1. Find the correct flow meter and the correct master valve from the dropdown. Before leaving control point 2, be sure and save everything. Remember, this is what my site hydraulics look like. Water source 1 is 3-inch and can supply 100 GPM, while water source 2 is smaller and can only supply 60 GPM. I prefer to use that larger 3-inch source on a regular basis, but use that smaller one as a backup. I want to change over to the backup water source before the water rates go up. Here's how I'll make that change. Go back to water source 1 and select Edit. The only change we're going to make is at water source priority. I've changed it to priority 4, higher than priority 5 in the other water source. Now it will use water source 1 exclusively until it's disabled or shut off. Earlier I set a 100,000 gallon monthly budget and selected shutdown. When it exceeds that budget, it will shut down water source 1 and automatically switch over to water source 2. If I had left water source 1 at priority 5 and water source 2 at priority 5, they would both be used at the same time. This is common at sites that need all the water sources at the same time. We're all done here, so save your work before exiting. The last item to work on under flow setup is mainlines. We only have one mainline on the site, so all of the zones are assigned to mainline 1. If we had two different mainlines and they were different sizes, I would put some zones on mainline 1 and some zones on mainline 2. Under mainlines, I'll add a description to mainline 1 to reflect its location. Like I did before, I'll set my design flow based on my mainline size in order to tell it mainline capacity. Sometimes when mainlines initially fill up, you can get high flow readings that later go away, but that cause alerts. You can give the system additional fill time under flow stabilization settings. Normally it starts taking readings after 1 minute, but I've just changed it to 2 minutes of pipe fill time. The system will ignore high flow readings for a full 2 minutes and likely stop those excessive flow alerts. There's no need to change this though unless you have high flow errors. The Manage by Flow settings enable the controller to run multiple zones at one time up to the design flow of 100 GPM. It might find 2 50 GPM zones or 3 33 GPM zones, all while staying under the design flow limit. It is important to go back into your programs and increase zone concurrency to make sure they work the way you would like. Under flow variance, I've just set the limit to 20% and then click Shutdown. Should the flow run 20% above or 20% below the expected flow, it will alert me and then shut down. If I don't select Shutdown, it would only send an alert and not shut down. A useful setting is Advanced Flow Variance. If I select the box Use on the right side, it will ignore the above flow variance settings. I'll get the option of adding a range of flows based on my expected flow. I've decided for flows 300 GPM and above, I'll only tolerate a 5% variance. For flows between 125 and 300 GPM, I'll tolerate a 10% variance. And then all the way down to flows 25 GPM or less, I'll tolerate a full 20% variance. You may need to experiment to find the right settings for these, but if you have a wide range of flows, this is very helpful. I can also shut down for high flows, but not shut down for low flows, just get alerts. There are times when getting some water applied is better than shutting down and getting none. Under zone assignments, here are all the zones that are assigned to each mainline. Since I only have one mainline, all my zones are assigned here. This design flow column will be populated with flow values after you've learned flow. It's beneficial to have a flow sensor and to get real-time flow, but if you don't have a flow sensor yet, you can manually input those flow values. It's time-consuming and not quite as accurate, but it will allow you to use that Manage by Flow feature. If you have a booster pump that needs to run only with specific zones, you can toggle on a booster pump at this point. Our flow setup is complete, so save your work before leaving. A reminder, if you haven't already done it yet, don't skip the Program Learn Flow or Zone Learn Flow operations. You can do this either at the controller or through Base Manager. It's that last piece in the flow setup. BaseStation 3200 controllers can accommodate 8 water sources, 8 control points, and 8 mainlines. That lends itself to a wide range of options that's difficult to cover in any video. If you reach out to Baseline for help with complex flow setup, gather your site information, and have a sketch ready. It'll make that process all that much easier.